Hi, my name's Tim Cruse. I'm a Principal Solutions Architect at Amazon Web Services, focusing on serverless architecture on AWS. We are so glad to have you joining us today for this series of webinars on processing at scale. In this particular session, Architecture Patterns Serverless Stream Processing at Scale, I will walk you through a set of architecture patterns used in stream processing and real-time analytics. Let's look at the agenda on what we are going to cover in this session. First, we'll go over a quick overview of real-time analytics on AWS. We will look at stream processing architecture patterns, then look at examples of AWS serverless architectures. After that, we'll look at how you can integrate security and compliance into the architecture. Finally, we will run through a demo to see the solution in action. The value of data diminishes over time. To get the most value from the data, it must be processed at the velocity in which it is created, at the source. Examples could be a patient's vital signs monitoring device and detecting anomalies. Sensor data from a locomotive train that is showing fatigue and stress in the brakes will telltale signs of an impending failure. A remote offshore rig sending out distress sensor messages needing maintenance, or a website needing to display product recommendations, or an ad based on user clicks and user profile. We want to ingest video and data as it is generated rather than wait for hours or days. From thousands of data sources, scale and variety of sources is important. We want to aggregate, filter, and enrich data before it lands in a data store. Make new data available for analytics and processing in seconds. Get insights in real time and react quickly. Examples could be credit card fraud detection or security breach at an airport. Streaming on AWS is made easy. Customers can collect, process, and analyze data and video streams in real time without having to deploy massive infrastructure. The Kinesis services work together and provide flexibility and options to tailor your streaming architecture to your specific use cases. Kinesis data streams allow you to collect and store streaming data and scale on demand. Kinesis Data Firehose is a fast and simple way to stream data into data lakes or other end destinations, again as scale, with the ability to execute serverless data transformation as required. Kinesis Data Analytics allows you to build, integrate, and execute applications in SQL and Java for more complex use cases. These three services work together to enable customers to stream, process, and deliver data in real time. Let's have a quick look at the following log ingestion architecture. Logs could be coming from EC2 instances, AWS Lambda functions, or from containers. The logs are ingested at scale using Kinesis data streams, and then can be streamed directly into Kinesis Data Analytics for real-time analytics or into Kinesis Data Firehose to push that data into Elasticsearch or stored into S3 to build your data lake for historic log analysis. This other example shows how you can monitor the state of IoT. We'll ingest sensor data via AWS IoT Core, who will pass this data to Kinesis data streams. Then, from the stream, we'll compute average device temperature for every 10-second window using Kinesis Data Analytics, and then persist the time series data aggregation into an RDS MySQL database. In this last example, we'll take an IT security view. If you have worked with IT security teams before, they will tell you to enable CloudTrail logs. You can enable these logs very easily within CloudTrail in your account. But do those teams actually analyze these logs? Here is an architecture that you could use to provide better information to those teams, analyzing AWS CloudTrail logs to detect patterns of misuse of resources or a security breach. First, we'll ingest the raw log data from CloudTrail into Firehose. Then from Firehose, we'll compute operational metrics off of the data by using Kinesis Data Analytics. And finally, we'll deliver this data to our users in real time in dashboards and databases for archival. Now that we understand the basics, let's talk about our demo. For this demo, we'll implement the following use case for Octatank Healthcare, who deploy medical equipment in hospitals across the globe. That equipment collects patient data and device data. We need to ingest, process, and analyze that data at scale in near real time, and our Developers don't want to manage IT infrastructure. Finally, our solution needs to be fully HIPAA compliant. This demo architecture pattern is based on a white paper that was written back in 2018. You can dig deep on the architecture and design patterns and examine the implementation details. One additional thing this white paper provides is a rough estimate of how much it will cost you to run the solution per month. The white paper gives you an end-to-end complete solution with a serverless application model template, similar to CloudFormation templates, for you to launch and test the solution in minutes. There are 3 distinct stages or modules in this architecture pattern. Module 1 is the ingestion of streaming data from a set of IoT sensors from hospital devices around the world. Notice the Lambda function that the AWS IoT Core Rules engine calls to do the de-identification of the patient information from the sensor message. This is to make sure you are HIPAA compliant. The de-identified message is then stored in low-cost storage like an S3 bucket. Cross-reference information is encrypted and stored in a DynamoDB table. Module 2 implements data enrichment by adding device detail information from a cross-reference database in DynamoDB. Using device ID in the sensor message, we pull additional device information. Module 3. The de-identification and enriched sensor messages are processed using Kinesis analytics for real-time analytics to detect anomalies in the patient's vital sign data or issue with a specific hospital device. Should there be an anomaly, an SNS message is sent to a healthcare provider. If there is an issue with the device malfunctioning, an SNS message is sent to the device manufacturer for maintenance. So for Module 1, this is what our raw ingested sensor data will look like. It will contain the patient's PII data. Our de-identification microservice running within Lambda will remove the PII data and ensure HIPAA compliance of our application. In Module 2, we enrich the data by looking up device model and manufacturer data based off of the device ID. Finally, in Module 3, by using Kinesis data analytics and an AI/ML forest cut function for anomaly detection, we produce an anomaly score based on the patient's vital sign dataset. Now, let's all see this in a demo. I have deployed the solution on my AWS account using the serverless application model template in GitHub. Open source, you can also deploy the solution and test it out yourself.
Thank you, Tim. Hi, I am Akhtar Hussain. I'm an Enterprise Solutions Architect here at AWS, and I'll be walking you through the demo for the solutions that Tim presented just a few minutes back. So to start with, let me show you the CloudFormation template for the solutions for the infrastructure. So this is the first for the first module. This is the CloudFormation template, and here are the parameters to the template. And here are some of the sources, the resources, the sensor data collection stream, the Kinesis delivery stream. Then I have some IAM roles, and then I have the IoT device simulator Lambda function. I will talk a little bit more about that in a minute. And then downstream, I have the de-identification function, Lambda function, that removes the AI data from the sensor or patient sensor data. And then here is the cross-reference patient's reference table in DynamoDB table. This is a DynamoDB table. So on the other module of the CloudFormation template, I have the Kinesis analytics application, and here is the definition for the rows. Here, basically, these are the patient's vital sign data, and here is the anomaly score that the random cut function is going to be called with this data, and the random cut function will calculate the anomaly score. So here is that template, and I use this template, CloudFormation template, to deploy the solution. And we can go to the CloudFormation service and look at some of the resources that have been deployed. I deployed this in the Singapore region, and looking through the resources, I can see what are those things that have been deployed, the resources that have been, the firewall's delivery role, the input stream, the application app starter, the kinetics analytics helper function, and on and on and on. Um, so one thing we can do is we can quickly test the solution. Now that the solution has been deployed, we can quickly test the solution. The IoT core provides a test capability to test the solutions. In order to test, uh, I need to subscribe to a topic, and I'm going to select this topic to subscribe to on the IoT core, and this is where I'm going to publish my messages, and we'll be able to see how they are associated with a with a rule and tied to a Lambda function in just a minute. So here is the topic, and I want to subscribe to this topic, and I have an ability to test that right here on the console. So I'm going to put some test data, and here is the test data. You can see the patient's name and the date of birth. So these are PII information or personal identification information. And in order to be HIPAA compliant, I need to be able, I should be removing these data before I send it downstream for the analytics. So I get this data here, and let me go back to the IoT core test area, and I am here, and here I publish. Looks like the publish went okay. The data went okay. So before we go and look at the logs for this, let's look at the sensor device representation here in the IoT core, and I have a rule against this, so I can see that the rules is subscribed to that, publishing it um, to that topic, the IoT topic, and then I have a Lambda function associated with that. So I can look at it to look and see what function it is that it is associated. It's the de-identification function that has been associated with that. I'm not going to make a change. I'm going to just cancel it out. Let's see how my test data went through. So I'm going to go to CloudWatch and look at the cloud log groups and see if I have the logs from that Lambda function. I do see that. I go in here, and I can see the event that was generated, and I can see the data that has come through. And here it is that you can see the PI data has been removed from this message, from the sensor message, and pushed downstream. So and I mentioned about the cross-reference data on the DynamoDB table. So let's see how the cross-reference data, for just in case and this patient has an issue or a problem, then you can see in the DynamoDB table and keep the cross-reference data, meaning the patient's date of birth and the name associated with the patient ID, so that in the event there is an issue with the patient, then you are able to get back to that patient and take corrective actions or whatever actions you need to take. So it seems that the solution worked end to end from the test. And I did a unit test with the IoT core test unit. So now I can open up my solution to the floodgates of the sensor data that will be coming in. For the purpose of this demo, I have used an IoT simulator, a device simulator, which is implemented as a Lambda function, and I have tied that to an event scheduler on CloudFormation. Here is the events rules, and we can look at the event. This is the event rule that I've created, and this is basically, if I look at the edit of, let me see when I can edit that. Hold on. So I can select this, and I can do an edit and have a look at it. Yeah. So you can see that this rule fires, scheduled to fire every 1 minute. And then associated with this is the Lambda function. And the name of the Lambda function is the publish to the topic. It is the IoT topic. And the function takes one input, and this is a JSON input. It says that fire 1,000 times or publish 1,000 messages to the IoT topic. So I am going to, what I'm going to do is now activate this rule. This is disabled at this time. You can see it turned into black. And now I'm going to enable this rule. So once I enable, basically it means that it will start to publish within a minute, start to publish messages to the IoT topic, and the whole the identification function will kick in, will remove the PI data and publish the data for downstream to the data analytics or the Kinesis data analytics application. So let's have a quick look at the logs are going through. If the messages are going through, one way you can look at it is you can look at the logs. The Lambda function is publishing, so I can see the data is coming through pretty good, pretty rapidly, and I can see all the data, all the PI data is being removed, and this is further going on. So let me take you to the Kinesis Amazon Kinesis Data Analytics. Here is the application, and I'm going to open the application and get to show you the details. This is the application details, and basically this application consists of a set of SQL commands, and in here you can see this is the definition for the input stream, and I can look at the so this is the call to the forest count function, random cut forest function, and here is the vital signs of the patient that is going in, and the anomaly score that comes out from this. So this is what, and then you have the output stream and all of that. So let's have a look at the analytics, and I can see that my source stream is coming through. I can see they're being pumped in, and let's go to the real-time analytics and see how the data is being calculated. I can already see some data coming in, and I can, given a minute, I can see the anomaly score being calculated, and you can see. So it does the buffering a little bit, so you can see that. Well, the thing is, I am not a doctor, obviously, and what I have done is the anomaly score. I've said if the vital signs, the vital signs that I provided through the sensor data, and the anomaly score comes out to be more than 1 as a threshold. I said if that is more than 1, for example, in this case, and a few other cases that you will see at the bottom, I said that the provider, the healthcare provider, needs to be notified. So I have a SNS topic. When it is identified that the threshold is expanded in its SNS topics, it publishes it to the SNS topic that pushes the message to the appropriate the health provider. So that's pretty much that I wanted to show you for that solution. At least one takeaway I would like you from this overall walkthrough of the solutions and the serverless architecture that I've shown. Hopefully, you can see the deployment of the solution in a serverless architecture. At least when you are creating a new application or a workload, you should challenge yourself and ask yourself why you cannot choose a serverless architecture instead of the regular EC2 instance-based or a container-based or other microservices-based architecture that you have. So you should challenge yourself at least for the new applications. And also, when you get a chance, and go to that white paper that Tim showed you in the beginning of the presentation. And then there is also a link to the GitHub, and you will be able to see CloudFrame template and for the solution, overall solution. You can take that and deploy the solution and be able to test it yourself. Well, thank you very much for attending this session, and hope that you have a good time for the rest of the sessions. And over to you, Tim. Thank you.
Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out the survey and let us know what you think.